Good morning everyone, my name is K. Gershon Pal. My register number is 19BQ180467. Today I would like to discuss about a topic called probability of false alarm in radar engineering. Let us see what is the probability of false alarm means. In a radar, leakage of power or a losses or a distortion of noise causes a false alarm. False alarm means it is detection of false target. It detects the target even if the target is not present and gives an alarm of there is a target in this radar. So in order to find or in order to solve this false alarm, we need to find the probability of noise in order to solve the probability of false alarm in the requirement of a threshold. Based on the threshold, we can find the probability of false alarm. Let us see. Whenever we introduce a signal into an IF filter, according to the Gaussian equation, when a signal is passed into an IF filter, it gives the probability of voltage in terms of voltage. Let us see the equation according to the Gaussian equation. In order to find the probability density function of a voltage, gives P of V is equal to 1 by root of 2 pi psi exponential of minus V square by 2 psi naught. Here it is the probability density function of an voltage in terms of voltage. Here it varies from V to V plus in the change of voltage. Here psi is called mean square value of voltage at 0. This is gives the Gaussian equation of in terms of probability of voltage. In order to find this Gaussian modify equation, in order to find in terms of amplitude, based on amplitude, gives P of R is equal to R square by psi naught exponential of minus R square by 2 psi naught. This is called Rayleigh equation in order of finding the probability of noise. Based on these two equations, we can find the probability of a false alarm. Let us see in terms of, as we recall, let us evaluate a probability for in terms of voltages as a requirement in terms of V1 and V2 gives the probability of noise is P of in terms of V1 range of R in terms of V2 gives limits V2 to V1 R square by psi naught exponential of minus R square by 2 psi naught. In terms of ranging from voltage of V1 to V2. Let us see. We all know that. Let us take a probability of finding the false alarm based on threshold is given as Vt. Let us take here is Vt as threshold voltage. So, in terms of finding the probability of false alarm or for noise, in terms of voltage gives P of Vt terms of R means amplitude in the range of infinity gives tends to infinity, sorry, uh, infinity gives r square by psi naught exponentially of minus r square by 2 psi naught, or in terms of gives r square by 2 psi naught. Let us modify this equation into this. Use x exponential of, eliminating this amplitude or constant term, gives e power exponential of minus vt square by 2 psi naught, gives the probability of an false alarm. According to this equation, we can find or we can detect the probability density function of a false alarm or noise equation. In order to find in terms of probability of false alarm or probability of noise, in times equation based on this probability of false alarm gives P of Fa is equal to 1 by Tfa of V. Here Tfa is called and time for false alarm and V is called the bandwidth. Let us see in a graph, in terms of graph, representation of graph. First, Tfa is equal to 1 by Pfa of into bandwidth. Here Tfa can be written as 1 by B of exponential of minus Vt square by 2 psi naught in terms of threshold and bandwidth. Let us see in terms of graphical, when the noise is introduced into an IF. Let us see, this is a noise. Here it is the voltage or initial voltage or psi, or it is called RMS voltage of noise, means mean square error of voltage of noise. And let us see apply. As per our requirement, we can, based on the voltage of threshold voltage is, we can detect the false alarm. Here it is called small t of k is called an peak amplitude of the first wave of the noise, which crosses the voltage, threshold voltage, and capital T of k is called an average of time of the one wave crosses the threshold voltage. So these are the equations, and these are the equations that we can used to find the probability of false alarm based on the time, and the equations based on the threshold. So like this we can detect the false detection of a target, false detection of the target. So we can find that there is no target in this radar. Thank you so much.